Okay, we're looking at solving linear systems by substitution. And our goal here is that by the end of today, we should be able to solve a system of two equations using the method of substitution. So in the previous lessons, we kind of talked about what it means to solve a system of two equations. In section B, we said we could do this by graphing. It involved finding the point of intersection between the two lines. And so more generally, we talked about that it means, find the value of x and the value of y, which we can represent as our point of intersection, that satisfy the two equations. This method of substitution is going to be the first of two algebraic methods that that we're going to look at. So this method of solving these systems is more like the methods we used for solving equations earlier on in the course. So let's just talk again a little bit about what we mean here. So if we've got this system of equations, y equals 2x minus 3 and y equals negative 3x plus 7, we know graphically that the solution is this point of intersection right here, x and y. It's the only point that is on both the red equation and on the blue equation at the same time. So what this means is that when we're at that point of intersection, the y value that we have in our red equation, so this y value here and this y value here have to be the same y value. Same and same, because we're at this point of intersection right here. And similarly, when we're at this point of intersection, the x for equation 1, like this x, is the same as this x. So we're getting a single value of y and a single value of x that are the same in these two equations. Well, if this y here and this y here are the same, and this y is equal to 2x minus 3, and this other y is equal to 3x plus negative 3x plus 7, then we can set all of these things that are equal to each other, like equal to each other. Like if y is equal to y, okay, and in equation 1, y is equal to 2x minus 3, and in the second equation, y is equal to negative 3x plus 7, we can set those two expressions that are both equal to y equal to each other. Now we've got an equation that we know how to solve, right? Because this just has one variable in it, x. So we can solve this by, adding 3x on this side and adding 3x on this side to get 5x minus 3 equals 7. And then we can add 3 here, add 3 here to get 5x is equal to 10, and then divide both sides by 5, and then get x is equal to 2. This gets us halfway done solving our system of equations, right? Because we want a value of x and a value of y that represent that point of intersection. So if we know that x is equal to 2, we have these equations up here that tell us that what y is. If we use that one right there, y is equal to 2x minus 3. If we know that x is equal to 2, we can sub that in over here. We get 2 times 2 minus 3, which tells us that y is going to be 4 minus 3, and that y is equal to 1. So the solution to the system of equations is x equals 2, y equals 1, or this point, 2, 1. Okay? So this is roughly what we're going to be doing in our method of substitution. Notice that to get this equation right here, we took something from our first equation and we put it in for y in this second equation here. Right? So we're going to be taking an expression from one of our equations and subbing it into the other equation. And that's where this method gets its name, substitution. And then we substitute again. again, we substituted here. We took our value of x and we substituted into our equation for y to get our final, the second part of our answer. Okay, so let's take a look at what this is going to look like, okay, when we actually solve by substitution. So here we've got our system of equations, y equals x plus 4 and y plus 2x equals 1. And what we have in our first equation is that y is equal to x plus 4. Okay? We know that in these two equations, the y's are the same and the x's are the same. So over here in our second equation, where we have a y, we can replace it with this x plus 4 because y is equal to x plus 4. So this is our first substitution. And we make that substitution, we will get, just to put the brackets there, okay, we're replacing y with x plus 4, and then we'll still have the plus 2x equals 1. Now, those brackets really aren't doing anything, so let's get rid of them. Okay. Now we've got an equation that just has x in it that we can solve. We are going to start by collecting our like terms. We've got an x and a 2x. So x plus 2x is going to give us 3x. We'll keep the plus 4 and the 1. We are going to subtract 4 from both sides, and that'll get us 3x equals negative 3. And then we can divide both sides by 3 to get x equals negative 1. So after doing that first substitution, we have half of our solution. X is equal to negative 1. What do we do with that x equals negative 1? Well, we know that y is equal to x plus 4. So we can take this expression here for x and sub it in here for x. This is our second substitution. So y is going to equal negative 1 plus 4. Y is equal to 3. And there's our value of y, the second part of our solution. So our solution here is x equals negative 1, y equals 3. Or if we want to write this as a point, the point negative 1, 3. Okay. So the green lines sort of show us where we've done our substitution. Now, in this one, it was pretty easy to see what we were going to substitute because we started with this x plus 4 all over on one side of our equation, and we were told that y was equal to x plus 4. Okay, and it made it easy to see that we were going to take this expression for y and sub it in here for y. Often, we don't see something like that. We see something that looks like this. Okay. Here's our system of equations, 3x plus 2y equals 14, and 5x minus y equals 6. We don't have one of those equations that is y equals, or x equals. I mean, it works equally well either way. So I've listed some steps down here that we're going to follow every time that we're solving an equation using substitution. So our first step is going to be make sure we can rearrange one of the equations to isolate one of the variables, okay? And so that means we want to get something, so it's going to be y equals or x equals something, okay? And we have a choice in how we do this. We can do this either with our first equation or our second equation, and we can either isolate x or y. So we look for the one that is going to make it easy, all right? And I said here, look for coefficients of 1 or negative 1. So I think with these two equations, we're going to focus in on trying to isolate this y here, because we can isolate this y without having to do any division, right? And what we're going to do here is we can subtract 5x from this side, subtract 5x from this side to get negative y equals 6 minus 5x. And then we want just y rather than negative y. So we're going to divide everything by negative 1. And when we divide everything, I mean divide everything, all of those terms. So negative y divided by negative 1 is just going to be y. 6 divided by negative 1 is negative 6. Negative 5x divided by negative 1 plus 5x. So that's step 1, done. Okay, we've got y equals negative 6x plus 3. Step 2, we're going to substitute this expression, okay, this 6x plus 5x, into our other equation for y. Okay. So 3x plus 2, and then we'll do the brackets in green again. All right, 2, and we're replacing that y with a negative 6 plus 5x. Okay. Now, in this case, we've got this 2 out in front of those brackets. So our first step to solving this equation, because now we just have an equation with x here, is going to be to use the distributive property. Take this positive 2, multiply it by, and I should do this in a different color. I'll do it in blue here. Positive 2 times negative 6, and positive 2 times that 5x. That'll get us 3x stays the same. 2 times negative 6 is negative 12. 2 times 10x, 10x equals 14. Okay. Then we can start, let's see, we've got like terms, 10x and 3x. Combine them to get a 13x. Then we can add 12 to both sides. Again, we're solving here for x. We're trying to get x all by itself. So 13x equals 26. And then divide both sides by 13. X is equal to 2. Okay. So we've did our substitution step. I'll check this off in green because that was where the green brackets were. And then we solved this equation for, in this case, we solved it for x. Now, in other cases, we're going to be solving for y, okay? But either way, we either solve for x or solve for y or whatever that variable is, and we're halfway there. Step 4, substitute the value of x into one of the original equations, okay? And then we're going to use that, in this case, to solve for y. So we can go back to this equation right here. Y equals negative 6 plus 5x. So if y is equal to negative 6 plus 5x, let's sub in our value for x. Y equals negative 6 plus 5 times 2. Okay, and we can evaluate this. Y is going to be negative 6 plus 10. Y is going to be equal to 4. And so there's our solution. 2, 4, or x equals 2, y equals 4. So let's take a look at a second example, and then we'll give you one that you can try on your own here. Here we've got 2y plus x equals 5, 2x minus 2y equals 4, and we've got the same steps listed above. Rearrange one equation to isolate one of the variables. So I think in this one, we're going to try to isolate this x here. It's the one that's almost, that's looking a little lonely all by itself. So I'm going to bring the negative 2y to the other side just by subtracting 2y and subtracting 2y. That's going to get us x equals 5 minus 2y. Okay. And then we are going to substitute that expression into the other equation. So where we see x in our second equation, 2x minus 2y equals 4, we're going to drop in 5 minus 2y, our expression for x. Now we want to solve this equation for, in this case, we're going to be solving for y. So we've got to do distributive property. Okay. 10 minus 4y minus 2y equals 4. Collect our like terms here. Negative 4 minus 2 is negative 6y equals 4. And then we're going to subtract 10 from both sides. 4 minus 10 is negative 6. And then divide both sides by negative 6. Y is equal to 1. So we've solved for y. Now we substitute that answer into one of the original equations. So I would use this one right here. X is 5 minus 2y. X equals 5 minus 2y. And let's sub in y is equal to 1. 5 minus 2 times 1. And let's solve this to get our value for x. 5 minus 2 is going to be 3. So x equals 3. And there's our solution. X equals 3, y equals 1, or the point 3, 1. So finally, use those steps. Try this one on your own. Okay. So if you're watching the video, pause the video, try solving this one. And then I'll go through the solution here, and you can kind of check your work. So if I was solving this one, I would try to isolate this y right here, because it's the one that's kind of by itself. I would subtract 4x from both sides to get y equals 7 minus 4x. And then this expression here, 7 minus 4x, I'm going to sub in here for y. So 3x minus 2 times 7 minus 4x equals 8. Now I've got my equation. I want to solve this for x. I'm going to do distributive property. Negative 2 times 7, negative 2 times negative 4x. So negative 2 times 7 is negative 14. Negative 2 times negative 4x is positive 8x. And that's still equal to 8. I'm going to collect my like terms. 3x and 8x is 11x. Minus 14 equals 8. Not 18, but 8. And then I'm going to add 14 to both sides to get 22. Divide both sides by 11. X is equal to 2. We're halfway there. I'm going to take this equation over here, y equals 7 minus 4x. And I'm going to sub in my value for x, which is x is equal to 2. So y will be 7 minus 8. Y will equal negative 1. So there's my solution. X equals 2, y equals negative 1, or the point 2, negative 1. Okay? So if you can do that, you're now good to go ahead and try the practice questions on page C2 in the learning guide.